My name is Jessica BLACKBAND, and I'm a Student Conservation Association intern working with the Great Plains Landscape Conservation Cooperative of the U.S. Fish and Wildlife Service. Today, I'm going to discuss what we know and what remains to be learned about how climate change is affecting the wildlife we share our planet with. Ecological relationships are incredibly complex, and our limited knowledge of them means that there is a lot of uncertainty about how species will respond to climatic changes. However, there are some general trends that ecologists have identified for anticipating species' responses to climate change. As temperature and precipitation patterns change, many species are no longer able to survive or reproduce in the geographies where they currently live. As a result, biologists are witnessing species shifting their ranges in response to climate change. These shifts will only become more dramatic as the global average temperature rises in the coming decades. You might expect that species would move poleward as temperatures rise, searching for cooler climates that resemble their previous habitat conditions. However, observed range shifts have been relatively unpredictable as species navigate a landscape affected by many ecological stressors. The ability of any particular species to adapt to climate change seems to be dependent on several major factors. First, species with greater genetic diversity in their populations will be more likely to persist in the face of climate change. This is because greater genetic diversity increases the likelihood that some individual organisms will be able to tolerate changing conditions and produce offspring with similar tolerance levels. Species with flexible diet and habitat requirements, known in ecology as generalists, are more likely than specialists to be able to tolerate changes in habitat and prey availability triggered by temperature and precipitation changes. In fact, some of these generalist species may even see their ranges expand as temperature and precipitation changes make larger areas of land, rivers, or ocean suitable for them. Unfortunately, many invasive species are generalists, and as a result, experts expect to see climate change have disproportionately negative effects on native species, as opposed to invasive ones, across ecosystems. The ability of a species to migrate in response to climate change might also make it more likely to persist. Animals such as birds have a distinct advantage over woody plants in this department. Lastly, the ability of species to adapt to climate change can be impacted by other landscape changes that are not related to climate. For example, species that are able to migrate in an attempt to find more favorable habitat face many barriers to movement, such as roads, cities, and agricultural lands that reduce their mobility. For some species, climate change may occur too quickly for adaptation to happen. In recent years, numerous species have been considered for listing under the Endangered Species Act because of climate-related threats. Climate change isn't just affecting species distributions and population sizes. It's also affecting the life cycles of many animals and plants. One prominent example is the sea turtle. The temperature of a sea turtle's nest site determines the sex of an individual sea turtle while it is still just an egg. Higher average surface temperatures may lead to altered sex ratios in sea turtle populations, potentially affecting reproduction rates and population dynamics. Temperature and precipitation changes can affect the life cycle patterns of other species too. Thousands of species of plants, birds, and mammals take cues from temperature about when to flower, migrate, or hibernate. Milder winters, hotter summers, and more intense precipitation events could significantly alter the life cycle patterns of plants and animals, with unpredictable consequences. Climate change has implications for ecological communities as well as individual species. In April 2016, coral reef systems worldwide experienced the largest bleaching event ever recorded, triggered by rising sea surface temperatures and threatening entire reef ecosystems. Although this event was triggered by a strong El Niño, it foreshadows what can happen as sea surface temperatures warm in our changing climate. In addition, higher levels of carbon dioxide in the oceans are causing ocean acidification, which can interfere with the ability of small marine organisms to build their calcium carbonate shells. These changes have ripple effects throughout ocean food webs, but they also threaten the human communities whose livelihoods and cultural practices depend on these ecosystems. It is at this ecosystem level where climate change impacts on wildlife are the most unpredictable. For species that are able to adapt to climate change by moving to more suitable habitat or adapting to changing conditions, survival is still not guaranteed. New species interactions will develop and novel ecological communities will form. It's extremely difficult to predict how these novel species interactions will shape ecological communities and the landscapes they inhabit. Conservation professionals are exploring creative opportunities for protecting biodiversity, such as assisting species migrations and protecting genetic diversity. They are working diligently to better understand how species responded to climate fluctuations in the past and how they might respond in the future, but much remains to be understood.